Now that you know how to identify whether something is inelastic, a recoil, or a collision problem, we can do math with it. So one of the things to remember in all of these problems, whether they're sticking together, they're not sticking together, or they come apart, is that total momentum is conserved. So what does that mean? Total momentum means that the momentums that are added together before and after are the same. So the total momentum before of the collision equals, or the coming apart, equals the total momentum after the collision or the coming apart. So my general equation for all three of these is m1v1 plus m2v2 equals m1v1 plus m2v2. Now, these aren't the same. This is before the collision or separation, and this is after the collision. What I'm saying is that the first object's mass times the velocity of the first object plus the second object's mass times its velocity will equal whatever the velocities change after the collision. Right, so the masses stay the same. Mass 1 is always mass 1, mass 2 is mass 2, but their velocities might change. But when I add up their momentums before, it's going to equal the momentums after. So we're going to specifically look at inelastic and recoil problems first. So in an inelastic collision, remember that what they're doing is they're coming together and then they stick together. So it could be something staying still and then it comes and it sticks, or they slam into each other and stick, or they're both moving and then they stick. But the idea is that I start out with two masses with their own velocities, and I end up with one mass, the combined masses, and one velocity. So before the collision is going to be in pink, after the collision is going to be in green. So after the collision, they're stuck together and move as one, so I'm adding my masses together. So here's an example. A car with a velocity of 30 meters per second and a mass of 1,200 kilograms crashes into a truck with a mass of 3,000 kilograms. That's at rest. This pink part is setting up the before. This is before they've crashed. The two vehicles stick together. That's the clue that's inelastic. What is the final velocity? So that's what we're looking for. And when we say their final velocity, that is, again, a clue that they're stuck together. So velocity, the first number I come across is 30 meters per second. That's V1. And that goes with the car that has a mass of 1,200 kilograms. So that's M1. The truck has a mass of 3,000 kilograms. So that's M2. And it's at rest. So that's one of those clues that it's got a zero velocity. So I take my first things, M1 plus M1V1, or M1 times V1, plus M2V2, these things before the crash. And then after the crash, because the masses don't change, it's M1 plus M2 times the new V, right? And it's their velocity, so they're stuck together, it's one thing. So I want to solve for this V, so I divide both sides by, in parentheses, M1 plus M2, and I bring it down here. Right? So I'm not subtracting one of them. This V is multiplied by both, so I have to treat this like it's one thing. I'm dividing both sides by the quantity M1 plus M2. So now I've solved for V, and I plug in the numbers. 1,200 goes with M1, 30 goes with V1, 3,000 goes with M2, and 0 goes with V2. M1 is still 1,200, M2 is 3,000. So I get 3,600 over 4,200 is equal to 8.57 meters per second. So it's a lot lower because what's happened is that this little car has bumped into this truck that was still, and then they're moving together. So the final velocity has to be lower than the initial velocity of the car. And here's a pictorial representation of what happened. I had a small mass with a velocity hitting a big mass that was at rest. So they're stuck together and their final velocity is going to be smaller, right? My vector is smaller. Here's another example. Two cars with a mass of 2,000 kilograms. So they both have that mass, crash into each other. The first car has a velocity of 40 meters per second, and the second car is moving in the opposite direction with a velocity of 20 meters per second. What is their final velocity? So crash into each other, their final velocity are clues that's an inelastic collision. They both have a mass of 2,000, so 2,000 is M1 and M2. The first car, which is V1, has a velocity of 40 meters per second, and the second car is moving in the opposite direction, so I have to add a negative sign here, and that'll be negative 20 meters per second. Did you catch all of that? So again, the masses are the same, 2,000, 2,000. The first car has a velocity of 40 meters per second, and the second car, because the words opposite direction are in there, have a velocity of negative 20 meters per second. So here's my general equation, m1 v1 plus m2 v2 at the beginning is equal to m1 plus m2 times v. So again, just like the previous problem, m1 plus m2 are both multiplied by v. So I divide both sides by m1 plus m2 in parentheses. And so now I've isolated for v. I plug in the numbers. 2,040 is m1 and v1. 2,000 and negative 20 are m1, m2, v2. And then 2,000 plus 2,000 are the two masses added together. So I get 80,000 plus negative 40,000 divided by 4,000 is 40,000 divided by 4,000. So my velocity is 10 meters per second. That means I'm going in the rightward direction, right? So this one, they have the same mass, even though I kind of drew them as different masses. But because this velocity is so much larger, their final velocity, this velocity wins out, and so it's going to be going in here. But because this was going in the opposite direction, it's not going to be quite as much. Plus, I now have the combined masses. So those are inelastic equations. These are recoil. So the general formula, and the reason why we do inelastic with recoil, is that it's pretty much the opposite, right? I start out with two things that are stuck together and have one velocity before the collisions. And then after the collision, and we call it a collision even though they're coming apart, they move separately. So each object has its own mass and each object has its own velocity. So this is like the backwards, the reverse of my inelastic equation, which was I first started out with two separate masses and velocities and now I combine them. Now in a recoil, it's the opposite. So the first example, a 2-kilogram cannonball is shot out of a 100-kilogram cannon at a velocity of 20 meters per second. What's the velocity of the cannon? So this is what I start out with, right? After it's shot out, the cannon has a velocity of 20 meters per second. So one of the things that's not said, but is assumed, is that the velocity at the beginning is 0. The cannon and the cannonball aren't moving. If you know anything about a cannon, you load the cannon in there, it's this big, huge thing, it's stationary, and then it shoots the cannon out. When it shoots the cannonball out, the cannon moves back, and that's called recoil. That's one of the reasons why we call this recoil. It's that kickback, right? So they start out together, and then at the end, the cannonball, which is much smaller, moves forward, so I'm expecting this one to move backwards. Clues that it's a recoil problem, shot out, right? So it's shot out of. So my cannonball is my first mass, that's 2 kilograms. My mass of my second thing is my cannon, which is 100 kilograms. Their velocity together is going to be 0 meters per second in this case. And afterwards, V1, my mass of my cannonball, that's the smaller one, has a velocity of 20 meters per second. So I'm looking for V2. So I set up my equation, m1 plus m2 times v is equal to m2 v2 plus m1 v1, or it could be opposite, it doesn't matter. I subtract m1 v1 from both sides, right? So I get this equation right here, because I'm trying to isolate for this. So I first subtract, and then I divide both sides by m2. So I have my equation, m1, quantity of m1 plus m2 times v, minus the after velocity times the mass, divided by the second mass. So this is supposed to be in green, but I forgot, which is why it's kind of like pink and green. So my combined masses here is 102. but it's times 0, so it ends up being 0, minus my first mass times the second velocity, 20 over 100, which is the mass of my cannon, ends up being negative 400 over 100. So the velocity of the cannon is going to be negative 4 meters per second. Yeah, it's going backwards. That's what the negative is. And it's not going to be as large as my cannonball because it's a really, really large mass. Second example, I have a 2,000 kilogram car carrying a 30 kilogram mattress on its roof and is traveling 40 meters per second on the highway. The wind causes the mattress to fly off backwards at a velocity of 10 meters per second. What is the new velocity of the car? So you may have seen this on the highway. Carrying a mattress on your roof is not a good idea. It seems like a good idea, but it's one of those things that just sort of like grabs the wind, and it's so easy to fly off the car. So this part is the setup, right? I've got my car, I've got the mattress on top, and they're moving together at 40 meters per second. This is what happens after. So the clue that it's recoil is that it's flying off backwards. And then what is the new velocity of the car? So this is recoil. I've got two things that are stuck together moving in this direction. The smaller thing moves off this way. The larger thing is going to continue moving forward, but it will have a new velocity. So I set up my equation. Recoil, m1 plus m2 times v, is equal to after m1 v1 plus m2 v2. I'm looking for the velocity of my car, right? Because m1 is car, that's what came first. So my mass of my car is m1, mass of my mattress is m2. This is my initial velocity right here. This is v2, but it's also going backwards, so I have to remember that it's a negative sign. So reminding that it's a negative sign, I then want to isolate for this time v1. So first I subtract m2 v2 from both sides, and I get m1 plus m2v minus m2 v2 is equal to m1 v1. And then I divide by m1, and I have the v1 here. So I plug my numbers in. m1 is 2,000 plus m2 is 30 times my first velocity, which is 40, minus my mass still stays the same for m2 times its new velocity, which I have to remember, ooh, that's got to be a negative number because it's flying off backwards, over the mass of my car, which is 2,000, right? That's m1. So then I plug in the numbers and I solve, and I end up with the fact that my velocity of my car increases a little bit to 4.75 meters per second. It's not increasing a lot, but it's increasing because it's gotten lighter, one, and the fact that the mattress is going off in the opposite direction kind of helps push the car forward. So two reasons why it's bad to carry a mattress on your roof. One, it's probably going to fly off because it's going to take a lot of strength to keep it down. And secondly, when it flies off and potentially hits another car, causes accidents, it's going to push you forward faster than you were thinking you were going to go. And so that might also cause an accident. So two very good reasons to get somebody to actually deliver the mattress to you.